Okay, so for today, what we're going to get into is a little bit more on the oil primary controls. Now, I've had a couple people ask me to maybe do a presentation a little bit more on a couple of the most common types of primary controls that are out there. So that's really what the main purpose of this lesson is to get everybody, students, familiar with some of the most common types of primary controls. So we're going to really be focusing on the main four here. We got the R8184G primary control, which is really like the most basic primary control that's out there. Then we're going to get into a little bit of the CARLINs, 5200s and 6200, and then we're going to do a little bit of the RIELLO, and then we're going to cover the R1784 A, B, P, and U Honeywell primary controls. So to begin, the Honeywell R8184G is like the most common first generation CAD cell primary control you will likely come across in the field. Very, very basic primary control. As long as all the functions and everything else on the burner is working the way it's supposed to, this control will be in a standby mode and just ready to get that call for heat and basically turn the burner on. Okay, so really how this burner primary control works is once power is applied through the limit control, and that's going to be through the black wire, and a call for heat from the thermostat completes the circuit between T and T, then the CAD cell, as long as it does not sense heat, the control will energize, and it's going to energize the orange wire. Okay, the orange wire is going to send power to our igniter so that we can send the spark to our electrodes. It's also going to turn on the motor on the burner so that we can turn the fuel pump as well. So once the flame is established and the CAD cell resistance decreases to fewer than about 1600 ohms, it's going to de-energize the safety switch heater that is inside the primary control, and it's going to prevent the unit from shutting off on safety. Okay, if the CAD cell senses flame, the oil burner obviously is going to continue to run until either the thermostat or the limit control is satisfied. So here is a schematic diagram of the R8184G primary control. So there is that little safety switch heater that I just mentioned in there. That little safety switch heater is what makes the little red button on the primary control pop. So what really is happening is it's basically working off of the resistance of the CAD cell. If the CAD cell doesn't sense a flame within a specific amount of time, this little safety switch heater is going to continue to heat up, and eventually what's going to happen is going to pop. It's going to make the unit go into a lockout. Okay, so it works off of resistance. So really, the wiring is relatively simple. I mean, our thermostat gets wired to TT, our CAD cell gets wired to FF. Our black wire is what's coming in from our limit control. Our orange wire is what's going to send power out to our burner motor, oil delay valve, if there is one there, and then you have your ignition transformer. Okay, so that's what the orange wire happens to go to. The white wire is nothing more than your neutrals, and those are just going to go back to your white wire. So when you're doing a safety check on the primary control, you have to turn off the power to the service switch. Okay, install a 1000 ohm resistor across the FF terminals to reduce the resistance and simulate a flame. Okay, it is okay to leave the CAD cell leads hooked up. So you're going to turn the service switch back on and make sure both the line and low voltage circuits are complete. Okay, this control should not energize because the resistor connected to the FF terminal stimulates a fire in the chamber, and if it does energize, you are going to replace the control. So virtually what you're trying to do there is you want to make sure that the safety does work. Okay, if it does not, turn off the service switch and remove the resistor. Disconnect one lead from the FF terminals. Turn on the electrical switch. The control should energize, and the burner should lock out based on the safety switch timing, which is anywhere between 15 and 45 seconds. Okay, if the control does not go off on safety, replace it, and make sure to check the timing on the new control. Really, when you're doing this, you want to make sure that the safety timing is roughly the same. So if you have a CAD cell primary control that has a 30-second timing, replace it with one that has a 30-second timing. Okay, you just try to keep that within the same parameters. Does it make a big difference? No. It's just kind of keeping the operation of a burner relatively the same. Okay, if the control does go off on safety, we connect the lead to the F terminals and press the reset button. Okay, the safety is working properly if this happens. So when it comes to troubleshooting this type of control, first off, you have to verify that electrical switches are in the on position and that the thermostat is set above room temperature. So be sure that there is not a fire burning in the unit. Okay, so remove the primary controls cover and visually check to see if the spring-loaded mechanism has locked off on safety. And if the primary control is not off on safety, check for proper voltage coming from the limit control. If obviously you don't have any power going to the primary control, chances are it's the limit that is open and you're just not receiving power. Okay, if there is sufficient line voltage, remove one lead from the FF terminals. If the burner starts, the problem is in the CAD cell sensor or wires. The CAD cell may be sensing light, or the wires may have a short in them. If the burner does not start, disconnect all the thermostat leads and install a jumper. If the burner starts, the problem is in the thermostat or its wiring. If the primary is off on safety, check the combustion chamber to be sure the unit is not saturated with oil. And if the chamber contains excess oil, follow your company's procedures to eliminate the oil. You should never ever attempt to fire an oil burner that is saturated with oil inside the chamber. It can actually be very, very dangerous. So when we're checking CAD cells, we can do it two ways. We can do it with the burner on, we can do it with the burner off. So if we're going to do it with the burner on, the first thing that we have to do is we got to make sure that we start the burner. Once the burner starts, you are now going to remove the jumper. Okay, and then once that jumper is removed, you are going to check the resistance. That resistance must be 100,000 ohms or more when the CAD cell is in the dark. When we're checking that sort of stuff, we're making sure that the CAD cell is indeed working the way it's supposed to. When we're doing it with the power on or with the burner on, you are going to remove the CAD cell lead wires from the primary control. You are going to start the burner. Once the burner starts, you are now going to put a jumper across the FF terminals. Once you do that, you're kind of tricking the primary control in thinking that the burner actually is lit. Okay, so the burner is going to turn on. Okay, once that happens, you are going to check with an ohm meter across those CAD cell leads. Okay, that reading should be less than 1600 ohms. If we're reading 1600 ohms, that's telling us that the CAD cell is indeed working correctly. Now, checking CAD cells and the primary, you're going to do the same thing. You're going to remove your lead wires from the primary control. You're going to start the burner. You're going to jump the FF terminal with at least a 1500 ohm resistor. You're going to control. The control locks out, replace it. If the burner runs, trouble is in the CAD cell. When you're checking resistance across it, infinity means you have an open circuit, which means you either have a cell that's defective or the CAD cell is not seated properly, maybe not seeing the light correctly. If it's greater than 1600 ohms, you may have possibly a dirty CAD cell or it's just not seeing the light properly. Okay, so when you're thinking about it and you're putting this into a smaller, simpler way of doing it, if the burner locks out on safety, you got to do two things. You have to check the primary control, one, to make sure that it's wired correctly, okay, and make sure you don't have like any loose connections or anything like that. Then you're going to check the CAD cell, okay. With an ohm meter, you are going to check resistance. Without an ohm meter, you are going to clean the cell or replace it. You're going to check the wiring, and you're going to check your flame and make adjustments as you see fit. So really, in a nutshell, the CAD cell is really, really important when it comes to any of our primary controls. So if we're taking an ohm reading across a CAD cell, if we're reading 0 ohms across it, that's telling us that that CAD cell is shorted. Okay, so we're going to want a short circuit. So what we're going to want to do is we want to check the wires, obviously. We want to make sure that the wires are intact, that they're not pinched, they're not arcing out against maybe the housing of the burner. So you want to make sure that's all good. If all that still checks out and you're still reading 0 ohms across that CAD cell, you're going to replace the CAD cell, okay? Less than 1600 ohms, but not 0, it means that the CAD cell and the application really is working pretty much the way it's supposed to. You don't have to do anything. If you have above 1600 ohms, but not like infinity, or your meter is reading OL, means that you are having a dirty or maybe a defective CAD cell. You have improper sighting or an improper air adjustment, which means the furnace is just not burning correctly. Okay, so you're going to want to definitely clean or replace the CAD cell and then recheck your ohm reading. Check the flame sighting, which means you're going to make sure that the air tube and flame retention head and all that stuff is nice and clean. You have nothing really obstructing the sight of the CAD cell, seeing the flame inside the combustion chamber. If you're in doubt, always replace the cell and then recheck it. And obviously, you're going to adjust the air bands to make sure that you have a proper flame and you're getting a good reading. Infinity resistance means you have an open circuit, so check for improper wiring. You're going to check for a loose CAD cell in the holder or even a defective CAD cell. Now, the CARLIN models are just slightly different than the Honeywell 8184G. So the CARLIN 5200, these model numbers can be found just above the thermostat and flame detector terminals. Your wiring diagrams are to the left, and the control timings are listed above the model number. So it's always important to always look at your terminals and your model and serial number to find this information, because honestly that's really kind of important to figure out what type of primary control you're really dealing with to begin with. So for example, you might look at a model, CARLIN model number, and it might have XXX has, you know, XX amount of seconds for trial for ignition, and X amount of seconds for recycle time, and X amount of seconds for valve delay on and trial for ignition and motor delay off and all that other stuff. So it's always good to see what the timings are for a particular type of primary control. And usually that stuff, of that information is going to be stamped like right down in this area here. It'll give you, okay, it has trial for ignition like 10 seconds, 15 seconds, whatever it may be. Okay, so the CARLIN primary controls, both the 5200 and the 6200s, they're similar, but they got some things that are different between the two. The first one is really they have a limited reset, or better known as a serviceman reset protection. Basically what this means is it's going to go into a latch up after 3 consecutive times without establishing a flame. It's going to go into a hard lockout. And in order to release it from that latch up, you have to depress and hold the reset button for about 10 seconds. After that 10 seconds, the 2 diagnostic lights that are on the primary control, they're going to kind of like blink alternately back and forth. And after about another 20 seconds, the light will stop blinking. Okay, once that happens, you are going to release the button to completely reset the primary control. Another feature that they have is called a recycle on flame failure feature. And what this is in the event of a flame lost during a run cycle within approximately 2 seconds, the 5200 will shut the burner off and the 6200 will turn off power to the oil valve and complete a motor delay off cycle. So after a waiting period of about 60 to 90 seconds on either one of these, the red LED light will flash for about 65 seconds. And then that control will attempt to reset or restart the oil burner. If the flame is established during the trial for ignition period, the burner is going to resume normal operation like nothing ever happened. If not, it's going to go into a lockout. The diagnostic LEDs on these primary controls have 2 diagnostic LEDs. You're going to see one that's red and one that's amber, or like a yellowish color. The amber on signals that the control is in a self-test mode. The red on indicates that the control is in lockout. If your amber and red are on, it indicates that the control has locked out 3 times during a single call for heat and is in latch up. Okay, red flashing indicates that the flame has been lost during a run cycle after trial for ignition. And if the amber one is blinking off every 3 to 4 seconds while the control is in the standby mode, indicates that the CAD cell is sensing light or a diagnostic fault, which prohibits startup. So wiring these types, it's relatively simple. Your thermostat and your CAD cell leads get connected to the appropriate terminals, TT and FF. Your 5200 is connected in the same way as earlier interrupted ignition CAD cell relays. Your black wire connects to your limit control. Your white wires are all your neutrals. Your blue is going to connect to your igniter or transformer. And your orange wire is going to connect to your burner motor. The 6200 control has both a valve delay on and a motor delay off feature, which can make the wiring slightly more complicated than the others, but really it's not too bad, just as long as you know where things go. The black wire, again, is connected to your limit control, so your black wire is your power. Your white wires are all your neutrals. Your blue wire connects to your igniter or your transformer. Orange wire is going to connect to the burner motor, and a violet wire is going to connect to the oil valve. The other wire that is on there is a red wire with a white tracer or a stripe around it, and that's going to receive constant power. So as you can see in these 2 wiring diagrams here. So the 5200, your black wire is your power, all of your whites. Your orange is going to go to your motor, your oil delay valve. If it's used, your blue wire is going to go to your igniter. With the 6200, you have your hot wire, so you're going to be connecting the red with white tracer and the black wire all together coming off of your power. Then you have all of your whites. Your orange goes to your motor, your blue goes to your igniter, and violet goes to your oil delay valve. Your CAD cell gets wired to the FF, your TT gets wired to your thermostat, and if it's set up to an alarm circuit, like a 24-volt AC or DC alarm circuit, then it would be wired to the AA terminals. So the operation of the CARLIN 6200 is each time power is applied to the red wire with white tracer, the control performs a boot up test to verify internal operation. So basically after about 4 seconds, the amber LED comes on and the test continues for 6 more seconds. And obviously if everything is all set and ready to go, the amber light turns off. If the test is not successful, the control is going to repeat that test until it is successful. Obviously, if it continues going into this self-test mode and nothing else happens, chances are the primary control is no good and you're going to want to replace it. When the call for heat is initiated, the amber LED turns on and there is a 3 to 4 second delay while the control again performs a safe start check. And if no flame is sensed and all internal conditions are correct, the LED turns off and the control enters a valve delay on mode. The ignition is powered and 1 second later the motor is powered. After completion of the valve delay on cycle, the control goes into a trial for ignition. The oil valve is then powered and opened. The flame should be established within the trial for ignition period of roughly about 15 seconds. And if the flame is not sensed by the end of the trial for ignition, the control goes into lockout. Okay, the red LED comes on. And if you are using the dry alarm contacts, those are going to close, sending off an alarm. So the control must be manually reset by pushing the reset button for 1 second and then releasing it. Once that flame is established, the ignition will remain on for a short period of time to ensure that the flame is actually stable and then will shut off. The burner will then run until the call for heat is then satisfied, at which time the power to the oil delay valve will shut off. The motor will continue to operate for the specified motor delay off period, and then once the cycle is complete, the control returns to a standby mode, ready for that next call for heat. Your RIELLO primary controls are in many ways a completely different demon than the CARLIN and the R8184Gs. These types of primary controls really are designed exclusively for only RIELLO burners. And as I go through this, you will hear my enthusiasm about RIELLO, because me personally, I can't stand them, but you know, they are what they are. So RIELLO primary controls, in combination with the coil of the oil delay valve and a CAD cell, monitors and controls all functions of the burner. So the primary control on these things really just does everything that the burner needs to do. An auxiliary tap on the motor windings provides a 46-volt AC power supply to operate the actual control. So the oil valve provides the starting and running circuit for the primary control through a logic board and safety lockout switch. The ignition transformer is integrated into the primary control and provides interrupted duty ignition. There is no thermostat terminals on any of your current RIELLO primary controls. An additional device, such as a switching relay, must be used for your low voltage thermostat connections. The RIELLO controls safety switch is equipped with a contact allowing remote sensing of your burner safety lockout. And should the burner lockout occur, 120 volt AC is supplied to the sub-base terminal number 4 on the primary control to activate any connected remote alarm systems. All wiring is connected through the control sub-base terminals on these particular types of primaries, and the wiring diagram is supplied with each control and serves as an insulator on the underside of the control. Okay, these diagrams should always be left in place to protect the printed circuit board on the actual control. When working with these controls, most experienced service technicians will refer to either a laminated troubleshooting guide type thing or some sort of card that is provided with the training manuals that go with RIELLO. Now, that's the beauty of RIELLO, is that when you're working on them, you have to technically be factory certified to work on them, because you have to go through a specific amount of training to learn how they work and how they're wired. So here is a wiring diagram of a RIELLO primary control right here in this box. So it takes some time. I'm not going to go really through the whole wiring of this type of furnace, but what you have to understand is that RIELLO, basically every operation for that burner goes through the RIELLO primary control. Your terminal 1 is what's operating like an oil valve. Your terminal 2 is like your neutral, different alarm contacts, all sorts of stuff that's going on inside that one particular type of primary. So what's really happening when you're dealing with these types of controls is, if all the components are functioning properly, and again, if they're all working properly, the control is in a standby mode until 120 volts is supplied through the limit control to terminal 5 on that RIELLO primary control. Then, if the CAD cell does not sense light, the control is energized, and terminal 6 is then powered, providing 120 volts AC to the motor. The auxiliary winding tap provides 46 volts AC to power the actual control. The motor starts and then establishes a 10-second valve delay on feature. The oil valve opens, supplying oil to the nozzle, and at the same time the ignition is powered. Once the CAD cell senses flame, the ignition circuit is open and the spark is then shut off. If the CAD cell senses flame, the oil burner is going to continue running until demand for heat is satisfied, whether by the thermostat or by a limit control if you're dealing with a boiler. And if the control does not sense the flame within approximately 5 seconds after your valve delay on, the control shuts the burner off on safety. If the CAD cell loses sight of the flame for whatever reason at any time during the firing cycle, the CAD cell control immediately is going to close the oil valve to prevent oil flow and then goes back to the valve delay on mode and makes one more attempt to relight. If it fails to relight after that one attempt, it's going to lock out. So when you're doing a safety check on a primary RIELLO control, you got to turn off the service switch, remove the control box from the sub-base, remove the CAD cell from the control box, replace the control box on the sub-base, turn the service switch, and make sure that line voltage is complete. The control should energize. The burner should go off on safety approximately 5 seconds after the valve delay on cycle. If the control does not go off on safety, replace it and be sure to check the timing on the new control. When you're troubleshooting your RIELLO primary controls, it is very good practice to check that the control box spades are in good condition, as well as the sub-base terminals, to make sure that they're tight and not loose. Verify that there is 42 to about 52 volts of AC between terminals 3 and 7 while the motor is running. If the burner stays in valve delay on, check the following before you actually finally condemn the control. You want to make sure that the CAD cell is not faulty or sensing light before the trial for ignition. You're going to want to make sure that the coil wires are reversed or not reversed on terminals 1 and 2 or on terminals 1 and 8. You're going to if you have an open circuit between terminals 2 and 8, you want to check it with an ohm meter. If the coil circuit is open, you are going to get a reading of 0 ohms. An open circuit between terminals 1 and 2, the reading should be about maybe 1,235 ohms or less. Now, plus, one thing is to really be important to note about all of this is that if you are dealing with these readings, you're dealing with the 530 SE primary control only. Okay, an open coil circuit on terminal 1 will cause the 483 SE control to lock out. If you have insufficient voltage between terminals 3 and 7 on it, it should read 42 to about 52 volts AC. Okay, if you have low voltage, check the incoming power supply. If there is proper incoming voltage, about 102 volts, then maybe you're going to want to change the burner motor itself. Okay, if a burner with the 530 SE control continues to purge and light off with immediate flame dropout, or the burner with a 483 SE control cycles on and off in quick succession, you're going to want to check the following. You want to make sure that the metal yoke for the coil is not missing or improperly installed. You're going to want to check the coil wires of 2 and 8. Make sure they're not reversed. There may be low resistance on the coil holding circuit between terminals 1 and 2. And the resistance should be anywhere between about 1,300 ohms, maybe plus or minus a little bit. And if the resistance is low, you're going to want to change the coil. Now, with all of that being said, and I'm pretty sure a lot of people are lost with what was just covered, this is why RIELLO is, in my opinion, a big pain in the ass. It is because of all of these different tests that you got to do to check the operation of these things. The way I go about it, if you want to work on RIELLO, you definitely need to have training to work on them. Me, personally, I can't stand them. I know about them. I've worked on them. I don't like them. Okay, I think it's just too far above and beyond what needs to be done when it comes to an oil burner. But hey, that's just my opinion. So the Honeywell R7184 is, again, it's different from your CARLIN and your RIELLO. Ultimately, really what you want to do is you got to learn the primary controls, learn the different features and how they operate. It's really extremely important to note that some Honeywell models utilize different wire color codings that's going to operate different components on the oil burner. Now, some of the standard features when it comes to this type of primary control is that it has a limited reset. Okay, this control, again, is going to reset only 2 times before it goes into a restricted lockout or latch-up mode. So the reset, the count returns to 0 each time a call for heat is successfully completed. To reset the control from latch-up, you have to press and hold the reset button. Okay, the LEDs will go out. You're going to have to continue holding that reset button for about 30 to 45 seconds until the light comes on again. Once that happens, it's out of latch-up and it will go back into its normal operation. Another feature that it has, it's called limited recycle. Should the flame be lost while the burner is firing, the control shuts down the burner, enters a 60-second recycle delay, and then it's going to attempt to restart. During the recycle delay, the LED will flash slowly, 2 seconds on, 2 seconds off. Do not confuse this with the burner being in lockout. Okay, if the flame is lost 3 consecutive times without successfully satisfying a call for heat, the control goes into lockout and then must be manually reset by holding in that reset button from 30 to about 45 seconds. The diagnostic LEDs that are on it is going to have 4 states. When the LED is on, it's telling you that the flame is present. If it's off, there is no flame. If you have 2 seconds on, 2 seconds off, it's in a recycle mode. If you have half second on, half second off, it's in lockout. The LED can also be used to check your CAD cell resistance, in case nobody ever knew that. Yes, with this type of primary control, you can use the LED to check your resistance. So when the burner is running after the ignition has turned off, quickly press and release the reset button. Hold it for roughly about a half a second or less. The LED will flash from 1 to 4 times depending on the CAD cell resistance. If the light flashes once, the CAD cell resistance is normal, anywhere between 0 and 400 ohms. 2 flashes means resistance is normal, anywhere between 4 and 800 ohms. 3 flashes is normal, 800 to 1600 ohms. 4 flashes indicates limited resistance of more than 1600 ohms. Lockout can occur above 4,000 ohms of resistance. Pump priming cycle is another feature that this control has, and that's to facilitate priming. The control can be placed in a purge routine by pressing and quickly releasing the reset button while the ignition is on. And if the control has not locked out since its last complete heating cycle, the lockout timing will be extended for up to 4 minutes, and the ignition will operate in the intermittent mode for this cycle only. It also comes with a communication port. Like many of the Honeywell residential combustion controls have a communication port that allows for data exchange between the control and other products such as diagnostic tools, modems, zoning controls, and stuff like that. Wiring the R7184 is relatively simple. Each model of the R7184, one thing that they have in common is that your thermostat and your CAD cell leads are connected the same, TT and FF. So with the R7184A, your black wire is connected to your limit control. White wires, again, is all of your neutrals. Sounds familiar, right? Your blue wire is connected to your igniter and your transformer, and your orange wire is going to be connected to your burner motor. When it comes to the R7184B, the B model has a 15-second valve delay on feature requiring the installation of an oil valve. Okay, this control has an added violet wire that connects to that valve. The other wires from the valve is connected to the neutrals, and all the other wires are consistent with your Model A primary control. Your 7184P model, it has both a fixed 15-second valve delay, valve on delay, and a burner motor off delay feature, which may be field selected to 30 seconds, 2 minutes, 4 minutes, or 8 minutes, or a fixed at 15 seconds. So you have the ability to just move the dip switches around to whatever you want those features to be. So in addition to the violet wire for your valve on delay, there is a red wire that connects to the limit control, while the black wire connects to constant power to achieve the burner motor off delay feature. And again, all of your other wiring is consistent with your B model primary control. The R7184U has all of the features of the P model with selectable on-off delays, plus low voltage dry alarm contacts that are located above the thermostat terminals. On the U model, you can adjust dip switches to enable or disable both the valve on delay and the motor off delay. This makes the U model control pretty much the same as the A control, but this way you need to stock one control on your truck. All other wiring is consistent with the P model. So Honeywell, when it comes to their designations and revisions and stuff like that, they like to print that stuff on their labels. So all of your Honeywells puts the model designation and revision information for the R7184 next to the control part number and or prints it on the side of the control. Okay, so the revisions are numerical and indicate which improvements or changes are included on that control. So for example, like a Series 1 control have different CAD cell indicator ranges. Your revision 2 may have changed the pump priming cycle from 45 seconds to maybe 4 minutes, or adding a limited control, whatever it may be. Your Series 4 or later controls have added safety features. For example, the Series 4 control detects flame 8 seconds into the valve delay on, or 30 seconds into the burner motor off delay. Okay, the control will go into lockout if one of those isn't detected. Okay, the reason why they do that is to prevent poor starts and shutdowns due to bad oil valves. So what that means to us is that these controls cannot be operated without an oil valve. So if the fuel unit must be replaced, you must use one with either an integral or an external oil valve. And it also means that you are replacing an earlier control with a Series 4 or a later control. You cannot simply just cap off the violet or the black wire as you would with any of those other earlier versions. Okay, so if you're looking at the side of the primary control, you'll see some letter number designations. Usually they're kind of like on the side like this. So this is actually your Series 3, and this is actually a Series 4 primary control. There is a Series 5 control that is out there, so you can actually check the Beckett website for more details on that type of primary control. I didn't really want to get into it with this presentation, but there is one that is out there. Okay, sequence of operation for your R7184. The U model is pretty much the one that is the most sophisticated out of all of those that we just mentioned. Okay, and it has a couple of different features on it. So really the first thing is it's a standby feature. So this is what happens when the call for heat is initiated. There is a 2 to 6 second delay while the control performs a safe start check. If no flame is sensed and all internal conditions are correct, the control enters a valve on delay mode, and the ignition and motor are powered for about 15 seconds. Then it goes into a trial for ignition mode. This is where the control is now going to power the oil delay valve, and it's going to open. Flame should be established within the trial for ignition of anywhere between 15 and 30 seconds. If no flame is established, at the end of that trial for ignition, the control is going to go into a lockout and must then be manually reset. It also has what's called a carryover. Once the flame is established, the ignition remains on for about 10 seconds to ensure flame stability, and then is going to shut off. The burner will then run until the call for heat is satisfied, at which time the power to the oil delay valve will then shut down. Then you have your burner motor off delay. The motor will continue to operate for roughly 30 seconds to about 8 minutes, depending on how you set those dip switches. And once this happens, the cycle has been completed, and then the control will now go back to the standby mode and then wait for the call for heat for the next cycle.